with our part 2. All right. So one of the things that is, what we all of us are dealing with at the current moment is basically the stock markets or earthquakes or whether COVID-19 will actually subside or not. So these are basically yes no questions. Will there be an earthquake? It is a yes or no question. Will the share market rise or fall? It's a kind of yes no question or like a true false question. So basically, if I want to decide or if I want to model yes or no based on certain input, what we have to do is logistic regression. The logistic regression is based on a particular function which is called the logit function. The logit function is on your screen right now. Okay, it is just a simple function 1 upon 1 plus e to the power minus x. And what is going to happen is whatever value of x you give, it is going to make it is going to make a map so that your output is lying between 0 and 1. That is what the logic function does. All right, so output has to lie between 0 and 1. So if it is less than a particular threshold, you will say it is false. If it is higher than a particular threshold, you will say it is true. Or the other way around, whichever is convenient to you. Now, what you have to do is, now I will explain that to you by using an example. Of course, so all R-based problems are explained through an example. So what I'm going to do is I'm going to take a simpler data set, not the earthquake data set. I tried to download the earthquake prediction data set from Kaggle. There is a website called Kaggle, Kaggle, and on that particular website, a lot of data is available, and you just have to register and you have to agree to the terms and conditions, and you can actually download the data from Kaggle and play with it. The once you start playing with the data, you will be also seeing that there are some classification related problems, there are some decision related problems, and using those classification and decision related problems, you are going to use it for training, and then you are going to use it for testing. So when it comes to finding the accuracy of any model, the testing part will give you the accuracy of the model. All right. So I'm not really going into the depth of accuracy modeling, but here is the technique of logistic regression. So what you have to see is you have to download the data from Jared. I mean, if you want, you can note down the website Jared Lander. So there is a book by Jared Lander. So the book by Jared Lander, I'm going to show you at the end of the lecture. The book is titled R for Everyone. And this particular book has a website. And on that website, there's a lot of data for you to learn and test and play with. You can use that data. Now, what people have done is, this is a subset of the data which has been, I'm just going to, who is the person? So what I am going to do is, I am going to read the data into the R environment. So you can read it by using read.table. That's a mechanism of doing it. And so rather, how to say, it's an old mechanism of doing it. You can also use read.csv. Now, one of the things that happens here when you are reading some data into the table, some of the data is in strings and some of the data is in numbers. Okay, so there is a numeric data and there is alphanumeric data. Okay, so you can use read.csv. So if you are able to see, if you are able to, I hope you are able to see my screen. So on my screen, what I'm going to do is, there you are. So on my screen, I'm going to just clean my console. Okay, so you can see right now here, there is this particular data set, that's ACS underscore ny.csv. Are you able to see that on the right side of my screen, bottom area? So there is this ACS underscore ny. If I have to read it, suppose, so how is the technique of reading ACS? I just say okay, and then I say read dot table. Either you can say read dot csv, or you can also use read dot table. So I'm just going to say okay, let us do that, read dot csv. If I do that, I just have to name the file which I'm reading, acs and underscore ny dot csv. Okay, and by default there will be header and it will be a separator will be there, because it is a comma separated value. You can read the data into the environment. Now here, once you have read the data into the environment, what is happening here is there is this family type and there is this num units. So if you just type str of acs, if I just do that, what it gives me is the structure of the data set. As you are, I have already mentioned earlier, what has happened here is, look, there is a family type. The family type says it is married, female head, female head, female head. This is the kind of data which has got married and female head, female head, female head, that kind of thing is there. Then the number of units are single detached, single detached, single detached, like that. Okay. Then owned rent is mortgage, rented, mortgage ranges kind of thing. So there are two kinds of variables. So heating fuel is gas, oil, gas, oil, gas, oil, all that is there. Now, what I can do from here, please understand, what I can do from here is, I have to actually convert this particular field into a factor field, into a level field. How do I do that? I can actually convert this. Now, if I just type ACS dollar family type, if I just do that, what will happen is it will give me such a long list. It will give me. Okay, so what do I have to do is I have to convert this particular family type into a factor field. How do I do that? I can do like this. Okay, so as dot factor, okay, ACS dollar family type. I just have to do that, and there you go. What has happened is it says factor with 3 levels now. Okay. So there are only 3 types of families. One is female head, the other one. Okay, so just type structure is yes again. So it has got family type with female head. So 3 types are there. Okay. Again, I can convert this number of units, single, detached, and all that. So let us actually create this. So ACS dollar, what is this? Number units, NUM units. Okay. If I see this, what will happen? So mobile home, single detached, mobile home, single detached, something is coming like this. What I have to do again, I have to convert this into a factor. Why do I have to do that? Let us learn it later. So I say num units is just as dot factor ACS डॉलर num units. ये क्यों करना है ये अभी थोड़ी देर में समझ में आएगा. Now, one of the things that my colleagues, some of my colleagues are here, okay, own rent is also here, which is a character field right now. So I'll also do the same thing with own rent. Now, you remember that, so either it is owned or it is rented or it is like mortgage, that kind of thing is there. So as dot factor, so ACS dollar own rent. So I can actually do this. I'm converting each of these things into some known variables. So year built and all that. So do the same thing with year built. So now look at this. What is happening here is I have to manually type everything. Okay. So instead of that, if you use the read dot table, all the conversion, all this point of conversion will happen at one go. Okay, what is the command which is given here? What is the command which is given here? Please see, it is read dot table and it is a strings as factors equal to true. That is what it is. यही करना है, strings as factors equal to true. ये मुझे ये कमांड में लिखना है और मैंने ऐसा लिख दिया तो ये ऑटोमेटिक ये सारा काम एक साथ हो जाएगा. ये मुझे बार बार नहीं करना पड़ेगा. So let us try to do that again. So I just remove this. Let us remove all this object and I am going to read the data. Okay, so reading the data. Now I'm going to read the data. So if I don't, if I have here, you see that I have used read.csv. Instead of that, what I'm going to do ACS, okay, read.table. Okay, so what is the read.table? ACS underscore ny dot csv. I've done that. And now I've say header equals to true. So it contains a header. It contains a separator equals to comma separator is there, comma separator, and I am also saying that strings as factors equal to true. And now you see if I do that, look here what has happened directly. All string values have come as factors directly. देखो इतना सारा manual काम नहीं करना पड़ता. Okay, so it is read.table which is advantageous and you can do whatever you want faster. Okay, तो मुझे जो चीज फास्ट होता है उसे सब मुझे करना है. Okay, so the advantage of R is it has got a lot of commands which can customize and speed up your work. So that's what I'm saying. So now I have now read in the data as a data frame. What I have to do is this is the data which is you can actually do this. If I just type head of ACS and I say 10, what will happen? It will display me the first 10 lines of the data. That is what is going. Okay. Now what I have to do is अब अच्छा इसमें अभी इंटरेस्टिंग बात क्या है इसमें मुझे करना क्या है व्हाट आई हैव टू डू इज आई हैव टू प्रेडिक्ट द टोटल इनकम ऑफ द फैमिली बेस्ड ऑन सर्टेन इनपुट्स ये मुझे करना है टोटल इनकम ऑफ द फैमिली बेस्ड ऑन सर्टेन आई हैव टू प्रेडिक्ट इट तो पहले हम इनकम वाला जो फील्ड है पहले देख तो लेते कैसा है ओके so what I have to do is I am now going to create a true false field. Now see, there is this ACS income. Now let us see this ACS income. If I just do that. Okay, family income. Let us do that. Now so many values are there. And if I want, I can plot a histogram of this family income. Okay, so how do I do that? Hist ACS dollar family income. Okay, if I just do that, some histogram will be plotted. So let us do that histogram plot. There you are. You are now seeing the histogram of the family income. Yes, दिख रहा है. Okay. Now what I am going to see is now here there is not a lot of bins which are available. So what we prefer is using a density plot. So a density plot can be generated using ggplot. So how do I do that? So I just say library ggplot2. I just load that library ggplot2. If I do that, then I will be able to plot it using a density plot. And then I am also using this library called useful. It is going to use it. Okay. Now, so I'll just do that library useful. ये मैंने किया. Now what is happening here? Look at this. Look at this. I am going to use this field as a training input to my model. ये मैं करूंगा. I am going to use this particular field as a training input to my model. Now look at the particular structure of the data. Let us look at the structure of the data. The data currently does not have any field which says income. देखो, you please tell me on the screen right now, is there any field which is saying income? Nothing is there. There is no field which has a income. So what I am going to do is I am going to create a field called income. How do I do it? As this, now the मेरा जो data frame है उसका नाम है ACS. ACS के अंदर एक नया field create करना है. So what I have to do? ACS dollar income. अगर मैंने ये किया तो इस नाम से कोई भी field नहीं है right now. I'm going to create a new field. So what do I do? How do I calculate this field? अगर मेरा इसमें फैमिली इनकम है, if it is more than 15,150,000 मतलब 150,000 से ज्यादा इनकम है, तो मुझे इसको ट्रू कर देना है और नहीं तो उसको फॉल्स कर देना है. That is what I am going to do. This is the command. You see. So what I am going to say with ACS do something. So there, what is the syntax of the with command? With command says I just have to give the data. So where is the data? My data is in ACS. So what is my expression? My expression is family income is greater than 150, 150,000. This is my expression. ये मैं expression कर रहा हूँ, and let us see what has happened. Now, if I just do the structure again. If I just do the structure again, and what will happen? ACS. Look here. A new field has been created, which is logi. What does logi mean? Logical field. A new field has been created, a logical field, and for the initial values 150, 180, etc. Of course, that is false. So it has created the value false here. For some areas where the value is true, it will become true. All right. Now what I have to do is, now I have to create the density plot. How do I have to do? If I have to do the density plot, so GG plot, what do I have to plot? I am going to put on the x-axis. What is this? Family income is going to be put on the x-axis. All right. So that is very clear. So what is my data requirement? Please see here. What is my data requirement? My data is in the ACS, all right? And in the x-axis, there is to be family income. ये मुझे डालना ही है. Okay. And then I have to put geometry density or geometry V-line. ये मुझे करना है. So now look here. What does this do? It will create a density plot. This is what it means. Geometry density. It will create a density plot. यही create करता है. This is a simplified version of the histogram only. Okay, ये थोड़ा smoothened version of the histogram. It just looks beautiful और कुछ नहीं. Okay, and then what do I have to do? At the x-intercept, that means at x equal to 150,000, I am going to draw a vertical line. ये इतना ही मुझे करना है. So this is how what I have done. Okay, so let us see. So on the x-axis, there is family income. So I am just saying I need the data ACS, and aesthetics. I say x equal to family income. If I just done that, okay. So ये GG plot मेरा by default मैं ऐसा रखूंगा तो कुछ भी नहीं होगा. I have to add something to do. What do I do? Geometry underscore density. Okay, and then I just say fill equal to gray. Some color I just do. If I want, I can put red color. Say, let us do the red. Okay, let us see what happens. Red होता है तो red होएगा. Okay, and then geometry density, and then I am going to put a vertical line. See that for every command I am typing in RStudio, the help is also coming together. That is why the RStudio is a much smarter IDE. If you start doing it with the the basic R interface, it is not very helpful there. So I can use RStudio much smarter. I can be much smarter and use the RStudio. So x intercept, I just use one x intercept equals to 150, 1, 2, 3, 4. So that is what 150 and 5. Okay, so this is what I am going to do, and let's see what happens. Okay, कैसा कैसा लग रहा है? Okay, so what I have done is I have created a density plot and with the field color as red. Okay, अच्छा लग रहा है ना देखने में? All right. So let us go to the next part. So I have created the density plot. Now what I have to do is, so why do I need to do this kind of thing? This is basically data exploration, first of all. So this is exploratory data analysis. So and then I need to create the logic model. देखो हमने क्या किया? House cost, number of workers, own rent. Own rent is a factor variable. Number of variables, then the family type. That is also a factor variable. So you can actually create a linear regression model. This is generalized regression model, GLM. It's called a GLM. And if Pawar sir is here, he will recall that during his master's work, we had also tried to experiment with R and tried to do such kind of modeling. Pawar sir might recall this. So income one, I just created this kind of model, GLM. So it is, what is GLM? Usually, if it is LM, it means linear model. The GLM means generalized linear model. Okay. So in the GLM, you have to put the formula. ये जो है formula है. What does this formula mean? This income is the outcome. So ये जो income है, इसमें सिर्फ true and false. It is true and false. So what I have to predict based on input values, whether the person or whether the family has more income than 150 ट्रिपल जीरो दैट मीन्स 150,000 से ज्यादा इनकम है कि नहीं ये मुझे प्रेडिक्ट करना है आई एम गोइंग टू गिव टू द मॉडल इनपुट एज हाउस कॉस्ट नंबर ऑफ वर्कर्स ओनर और रेंट owned or rented I'll say number of bedrooms and then say family type I'll just give all these inputs and it will come out with the output okay यही मुझे करना है so this is how it is trained and in this training you will see a very good number of p values are coming it will also tell you whether your fitting is good or not okay so and you can also do a coefficient plot which is like this now let us go back to our hypothesis testing remember we had started hypothesis testing I do not know whether I mean I guess in your previous lectures ANOVA sorry one sample hypothesis test two sample hypothesis test they have been covered if they have not been covered I will try to cover them as in a brief manner okay so what I am going to start is the hypothesis testing in a t-test okay when we are talking about t-test what is the mechanism there is something called a single sample test and there is a paired sample test. Number two, the t-test will generate a statistic which follows the student t distribution. So whatever values you have to read from the t table. There's a t table in the statistics book. You have to read from the t table. In case you are not able to read from the t table, you don't have the t table with you, then what is the mechanism is you can use R and the values can be calculated directly आ जाएंगे. Now, one sample t-test. What is one sample t-test? When do I use one sample t-test? I know the population beforehand. I know the population mean beforehand. इसका मतलब, for example, I can say the average height of an Indian girl. If I just try to make a generalized statement, the average height of an Indian girl is 5 feet 4 inches. Okay, so this is a statement about a population. Now, from this population, the India population, I just randomly pick up some people and then I call the particular people or the set of people as the sample. So sample is a subset of a very big population. That is what I am saying. Now, what do I have to check? I have to check for the sample whether this is equal to or not equal to. तो यहाँ पे ये जो equal to and not equal to, please remember in our discussion which happened earlier, we had also mentioned very repeatedly again, जब भी मैं greater than या less than prove करना चाहूंगा, it will become a one-tailed test. If I want to prove it as not equal to, it will become a two-tailed test. Is it clear? Please tell me if it is clear or not. When I want to prove it is a not equal to, it will become a two-tailed test. Whenever I am going to prove it as greater than or less than, it will become a one-tailed test. Okay, so this is all about it. So what do I have to do is I have to check whether the particular population mean agrees with this existing data or not. Okay, now there is also something called a two sample test. So I've got two sets of data. I've got two sets of data, and I have to prove whether the two means are similar or not, or whether one mean is greater than the other. If it is greater than the other or less than the other, automatically it will become a one-tailed test. If it is smaller, if it is not equal to, then it will become a two-tailed test. Very clear. Not equal to बोले तो two-tailed, and greater than बोला या less than बोला तो ये one tail. Clear? This is what it is. फंडा इससे ज्यादा कुछ भी नहीं है. So the t statistic can be calculated by this simple formula. ये formula simple है, इसमें कुछ नहीं. अगर आप single sample वाला formula है तो यही use करना है आपको. Okay. So then okay, so what do I do is I am going to use the tips data. तो ये tips data क्या चीज है पहले आप समझ लीजिए. Tips data क्या है कि आप लोग suppose you people go to the hotel, okay, the restaurant. You people go to the restaurant, and after you go to the restaurant, you will see that there are female service people and there are male service people. Now the question is whether males are tipped well or females are tipped well. So the question that I'm going to ask, the ultimate question, are males and females equally tipped? आपको क्या लगता है beforehand? आपको क्या लगता है? Do males and females get the same tips or similarly tipped? आपको क्या लगता है? So, any answers? Yes, hello. Am I audible? हेलो.
Yes, sir, you're audible.
हाँ लेकिन वो कोई बोल नहीं रहा. Okay,
So
so
females will
female.
get the more.
Okay.
Yes, sir.
Okay. So now let us see from the data. ये तो आपका hypothesis है कि females को ज्यादा मिलता है. ये आपका hypothesis है. We will talk about whether it is true or not in using the data. Okay. So because the data is going to speak the truth. So, okay, so what I have done is I have taken the tips data from a particular restaurant and it is displayed here on this particular. So not all of the data which is available. There it contains a lot more data set, but it's a section of the first few lines of the data set which is available. It is also showing you that there are more, in the first few lines you are seeing that there are less of females and more of males. Okay, so automatically there has to be some some has judgment on that. So now what you have to do is you have to run the t-test. Now remember, I have to say not equal to. If I say not equal to, that means it becomes a two-tailed test. Okay. If I say less than or greater than, it will become a one-tailed test. So I'm going to run a two-tailed test. Okay. So let us see this. So here, and I have run the one-tailed test now here. Now let us do this. Male workers and female workers tipped equally, ये क्वेश्चन करना है. तो फर्स्ट ऑफ ऑल वी विल प्लॉट द हिस्टोग्राम. लेट अस डू द हिस्टोग्राम प्लॉट. देखो हिस्टोग्राम प्लॉट में होता क्या है, मुझे ऐसा मिलता है. नाउ कैन यू टेल मी व्हाट इज द इंटरप्रिटेशन ऑफ दिस हिस्टोग्राम? आई मीन डायरेक्टली सेइंग व्हाट इज द इंटरप्रिटेशन ऑफ दिस हिस्टोग्राम. क्या बोलता है ये? आर मेल्स गेटिंग मोर टिप्स or females getting more tips? So one of the things that you have to do is, see, in the initial days you have to start exploring the data through the graphs only. Please see here that the color that we use to represent the data is pink for female and green for male. So what is happening is, in the initial part of the graph, that is 2.5, these values are in dollars. So in the initial part of the graph, these values are, more for the female. The females are getting, for the denomination of $2.5, more females are getting tipped. Even for $5.0, more females are getting tipped. But when it comes to higher values of tipping, what has happened? Males are getting more tips. That's very interesting. And because this is the case, so there has to be some balance somewhere. So can I run the t test? So what I have to do is, हमें प्रॉब्लम ये है कि भाई, if you look at this graph, it looks like this particular distribution is not normal. ओके, ये डिस्ट्रीब्यूशन नॉर्मल नहीं है, तो टी टेस्ट चलाने में थोड़ा सा डिफिकल्टी हो सकता है, शक्ल से नॉर्मल नहीं लग रहा. Okay, so what do? I have to do is whether the variances are same or not. We are going to check whether the variances are same or not. So first of all, whether the variances are same or not, we can judge it by using the Ansari-Bradley test. So there is this Ansari test. Okay, so this tip, we are going to compare the tip based on the gender. Okay, the variable name is sex here, don't bother about it. But it is tipping based on gender, that is what. Now here, if you see the p-value, look at the p-value here. And this p-value is going to be very, very sensitive thing for my entire hypothesis testing. Suppose that my level of significance alpha is 0.05. अगर अल्फा से बड़ा वैल्यू आया, इसका मतलब नल हाइपोथेसिस सही है. अगर अल्फा से छोटा वैल्यू आया, इसका मतलब अल्टरनेट हाइपोथेसिस सही है. Now look at this. My alpha is 0.05. Look at the p-value. It is 0.3. That means ये alpha से बड़ा है, which means the null hypothesis is true. That means, according to the Ansari-Bradley test, the null hypothesis of the Ansari-Bradley test is variances are equal, and this is what this particular test proves. The variances are equal. Okay, and so therefore I can apply the t-test, and I'm going to apply the t-test. If I apply the t-test, it again says, देखो भाई, हमारा p वैल्यू क्या बोल रहा है यहाँ पे, 0.1665. What is my alpha value? My alpha value is 0.05. ये वैल्यू जो है, ये क्या बोल रहा है, ये वैल्यू 0.05 से बड़ा है. That means it is more than 0.05. Since it is more than 0.05, इसका मतलब क्या हुआ? इसका मतलब ये हुआ, males and females are equally tipped. इसका मतलब ये निकलता है. Now we are going to do the paired two sample t. अब pairing कब होता है? Before and after treatment. Okay, say for example अपन ने बोला कि क्या बोलेंगे, कोविड का इंजेक्शन की ले. ओके, कोविड, आप पेशेंट जब अंदर आए थे हॉस्पिटल के, आपको कोई मेडिकेशन दिया गया, उसके बाद आपका क्या रीडिंग था, और मेडिकेशन के पहले क्या रीडिंग था. आपको बुखार थी, आपको क्रोसिन दिया, उसके बाद क्या रीडिंग था. सो दिस इज बिफोर एंड आफ्टर ट्रीटमेंट. So like typically fathers and twins are not measurements on twins. So wherever there is a pairing, मुझे suppose I say in civil engineering, environmental engineering, I'll say that the air quality index of this particular place, this particular latitude and longitude is 140, and after running the sprinkler, it will become 40. पहले 140 था, अब 40 हो गया। सो ऐसे करके एट द सेम प्लेस आई मेक टू रिकॉर्डिंग्स एट द सेम प्लेस फॉर द सेम ग्रुप और फॉर द सेम पर्सन। दिस इज वेयर द पेयरिंग रन्स। सो पेयर्ड सैंपल टी टेस्ट तब रन किया जाता है जब मुझे पहले का वैल्यू पता है और आफ्टर का वैल्यू पता है, then only we do the paired test. So this is a test which is going to examine whether father's height and son's height are the same or not. ये टेस्ट करने जा रहा है। ओके, सो फादर, मेरे ही फादर और मैं, so this is like this, so there is a pair. Okay, father's height and son's height, so they are going to compare. If you look at this first line here, the father's height is 65, and remember these values are in inches है। ये वैल्यूज मतलब आप कंफ्यूज मत होना, 65 फुट नहीं है, ये 65 सेंटीमीटर नहीं है, these are values in inches है, please be careful. So father's height is given in 65.04 and son's height is given in 59.77. So these values are given, and what I am going to do is I am going to run the t-test, and the t-test is very simple. T-test father-son height, I am saying paired equal to true. ये मुझे करना है, and look at the p-value now. Can you tell me what the p-value says? Is it greater than alpha or less than alpha? Can you tell me? Can anybody tell me whether this value is greater than alpha or less than alpha? ये वैल्यू जो यहां दिख रहा है, remember that alpha is 0.05. ये जो वैल्यू है, what is this value? This is 2.2 into 10 to the power minus 16. ये greater than है कि छोटा है?
छोटा है सर।
लेस देन।
इट इज लेस देन। अगर लेस देन है इसका मतलब ऑल्टरनेट हाइपोथेसिस सही है। ओके, ऑल्टरनेट हाइपोथेसिस सही है, इसका मतलब फादर की हाइट और सन की हाइट बराबर होगी या सेम जैसी होगी, कोई गारंटी नहीं है। अकॉर्डिंग टू द डाटा, एज पर द डेटा इज कंसर्न, सेम होगी ऐसी कोई गारंटी नहीं है। तो दिस इज व्हाट रनिंग द टी टेस्ट टेल्स अस। ओके, now we are going to come to the concept of ANOVA. Okay, so now अभी एक चीज यहां पे ध्यान में रखना पड़ेगा कि ANOVA जब अपन चलाते हैं ना, तो the trouble with ANOVA is that the data, how we store the data in the Excel, and the data how we store in R is a different way. So please let us understand how we store the data. Okay, so हम क्या करते हैं, मैं एक आपको एग्जांपल दिखाता हूं, एंड प्लीज सी दैट एग्जांपल, एंड वेयर इज इट, ये कहां सॉफ्टवेयर गया ये। ओके, so what is ANOVA? And remember that you can run the ANOVA only if your data distribution is normal. Otherwise, don't try to run the ANOVA. Okay, अगर ANOVA normal distribution नहीं है, then it will become a problem if it will give wrong results if you run the ANOVA. So what I'm going to do, this is basically a spreadsheet software. This is LibreOffice, मेरा बहुत फेवरेट है सॉफ्टवेयर। और इसमें देखो अभी क्या है, ट्रीटमेंट 1, ट्रीटमेंट 2, एंड फिर उसके बाद यहाँ पे मैं बोलता हूँ नो ट्रीटमेंट। सपोज मैं ऐसा बोलता हूँ, okay, and I am just going to put some values. Okay, that's it, don't worry about these values, I'm just saying, just going to put some values. Okay, ये treatment हो गया। Okay, I'm just randomly putting some values, there is no, this is not pre-calculated, and okay, okay, and now my requirement is to find out whether there is a difference between these treatments or not. ऐसा ही करना होता है ANOVA में। So there is a standard formula for ANOVA, and अपन ANOVA में एक आध ये जो है ना वैल्यूज कम भी हो सकते हैं, नो प्रॉब्लम। सो फॉर एग्जांपल ये इसमें एक वैल्यू कम किया, इसमें 3 वैल्यू कम कर दिए. So it is possible like this also. Okay. So anyway, what I have done is I have created 3 different columns, and what I want to do, what I want to know is whether ANOVA is applicable or whether these 3 treatments are different or not. So I just want to say the null hypothesis is very simple. These 3 different treatments are not different, and the alternate hypothesis will be definitely that these 3 treatments are different. So ये LibreOffice है. In LibreOffice you can just use data, and there is going, you can go to statistics, and there is analysis of variance directly है ये. Okay, data, statistics, analysis of variance. अगर मुझे single factor करना है, because there is only 3 treatments which I am going to process, and results to ये क्या होगा, ये मुझे select करना area, ये cell select किया मैंने, और करने के बाद और मुझे अल्फा सेट करना है. अल्फा रिमेंबर लेवल ऑफ सिग्निफिकेंस 0.05, and I am just going to say okay. As soon as I say okay, ये मेरा पूरा कैलकुलेशन होके आ गया. लुक एट द पी वैल्यू. क्या बोलता पी वैल्यू? मेरे अल्फा से, दिस इज माय अल्फा एंड दिस इज माय पी वैल्यू, ये बड़ा है कि छोटा है? दिस इज अल्फा एंड दिस इज पी वैल्यू. बड़ा है छोटा है? ये बड़ा है ना. 0.741 is greater than alpha. Since it is greater than alpha, that means there is no difference between these values. That means there is no difference between them. Now suppose, for example, I just do 123 and I just add some more, like 456 and 564, something like that. I just add some more bigger values here. Avi, look at the p value now. ये क्या हुआ p value को? p value छोटा हो गया, बड़ा हो गया?
लेस, छोटा हो गया.
छोटा हो गया. अगर p value छोटा हो जाता है, इसका मतलब they are different. That means this f is significant. Okay. This is the calculated f and this is the critical value. Calculated value is higher than the critical value. That means alternate hypothesis is true. तो ये एक तो ये तरीका है by comparing the calculated f and the critical f. और दूसरा तरीका ये है कि p values को compare करो. ये that means you have to compare alpha and the p value. Okay. If it is less than alpha, if the p value is less than alpha, that means alternate hypothesis is true. So this is all about it. But in R, if I have to do, okay. So in R, if I have to do what okay, let us do this, and I'm going to clean my data here. Okay, so what I'm going to do is I'm just going to calculate my data. Okay, and I am going to use a default data set which is available with R, which is called planned growth. Okay, and it has got 30 observations of two values. If I just type my data, ये देखो मैंने अभी my data से लिया, देखो 30 observations of two variables. Can you see what is happening here? Ideally speaking, मेरे पास 3 कॉलम होने चाहिए, एक में CTRL, एक में TRT1, एक में TRT2. Ideally speaking ऐसा होना चाहिए, लेकिन ऐसा है क्या? ऐसा नहीं है. What is happening is I have been given the data in a column. Okay, I have been given the data in a column. Okay, simple column में दिया हुआ है, और मुझे ऐसा ही फॉर्मेट में in R I need the data into this format. And if I don't have the data into this format, I have to use a command. आप लिख लीजिए command को, and you can search on Google on how to run this command. So there is a command called melt, MELT. You can use the command melt to create a table like this. In case you have the LibreOffice table like this one, ऐसा अगर table है तो मुझे command use करना पड़ेगा melt. Okay, so the melt command can create this particular वेरिएबल सिस्टम. नाउ अगर मुझे इस पे एनालिसिस करना है ANOVA का वन वे एनालिसिस ऑफ वेरिएंस, दैट मींस व्हाट एम आई गोइंग टू टेस्ट, whether there is a difference in the treatment or not. First thing, whether there is a difference. If there is a difference in the treatment, then which is the best treatment? एक तो ये सब करना है. Okay, and then please remember that the assumption in the ANOVA is that all variances, the variations of the data, variance of the data is the same. Data from where it is being collected is the variance is same. ये basic assumption है इस particular test में. Please remember that in the Wilcoxon test that we had discussed earlier, there is no such assumption. It is just like that. Okay. In the Wilcoxon test, there is no such assumption. In this particular test, we have to assume that the variances, that means they must be equal. ये हमको assume करके चलना पड़ता है. ये बड़ा दिक्कत वाला काम है. So anyway, so let us go. This is how what the data looks like, and what we have to do here is now see. What I have to do, I have to find out the levels. Okay, so how do I do find out the levels? Very simple command है. ये अपना देखो ये already levels में है या नहीं, तो ये levels में है. Okay, so what do I have to do? I just have to say levels, and then the data is in my data, and my data और उसका group. Okay, देखिए my data का group मुझे field चाहिए, तो I just have to type dollar. My data dollar group type किया तो ये सारे fields मेरे आ गए. Okay, this is what happens. So on your screen right now, you are seeing which levels are available. That means I have a table which in which there is this column which is named CTRL. That means the control group. Control group वो होता है जिसको कोई treatment नहीं देते. Okay, and there is one column which has got the treatment 1, the first kind of treatment. There is another column which is giving the second kind of treatment. All right, so what we have to do is, okay, so where are we now? All right, so what we have to do is this. Okay, so I have found out the levels, and I can actually create a kind of a statistics. If I just so I'm just can do display the summary statistics. That's not important, but we have to first of all understand visually understand the variance. And how can I visually understand the variance? By using the box plot. So you can also do the GG box plot or Geom box plot, that wherever you want. So GG box क्या है कौन है ये? Okay, so I want now the GG box plot. ये मुझे कैसे करना है? So let us do that. Okay, here. So first of all, we will load the publication library जिससे मेरे ग्राफ्स जो है सुंदर दिखे. ओके, सो जीजी पबार ये क्यों यूज करना है? मुझे ग्राफ सुंदर चाहिए. आई वांट ब्यूटीफुल ग्राफ्स. सो हाउ डू आई मेक माय ग्राफ्स ब्यूटीफुल? बाय यूजिंग द जीजी पबार लाइब्रेरी. Okay, now what is required is, first of all, the command is gg box plot. Okay, so this is gg box plot, very simple. So now the help is also coming with it. First of all मुझे data देना, तो data is in my underscore data. Okay, and then data दे दिया मैंने, फिर मुझे x देना है. x axis में क्या होगा, y axis में क्या होगा, and then that is what I'm saying. So x equal to, now please remember ये क्या है group. Okay, group. Okay, please see this, that gg box plot command is much more closer to the basic box plot command. बहुत लोगों को ऐसा पसंद नहीं है कि यार अरे ये जो हमारा ये चल रहा है. So what I am going to do is color by group. Okay, each group will have a different color. So each box plot will have a different color. If you don't want the different color, doesn't matter. Okay, so y lab. So what will be the y lab? Y label. Y label is weight, and then x label equals to treatment. Okay, so okay, if I do that, let's see what happens. So I have used a shorter version of the original plot. Please understand that I have used a shorter version. That means I didn't really bother about using the same commands, but it just works, no problem. Okay, I can eliminate some of the workers. So look at this particular, ये जो treatment है, this treatment 2 and this treatment CTRL, इसके ये वाले पार्ट्स ओवरलैपिंग है, ये जो ट्रीटमेंट 1 है CTR है, इसके ये वाले मेजर पार्ट्स ओवरलैपिंग है। ओके, तो अब देखो यहाँ पे ये और ये ओवरलैपिंग नहीं है। यूजुअली आई वुड each other. This is what I can visually say from the data. But are they different from each other? That is what I'm going to investigate. Okay. So how do I investigate? I can investigate using my ANOVA. Okay. So let us do that. So what will happen if I do that? I will get this kind of graph which I've got right now. Okay. So now I am going to compute the one-way ANOVA. So weight as per group. This is weight against the group. So let us see this weight against the group. So result, and so I'm just saying, okay, mera result. I can just put mera underscore result, no problem. This is just a variable. Okay, the command for analysis of variance is AOV. Okay, so result AOV. So what is the formula I require? So weight as an output to the group that we have. Okay, so this is the group which we have, and then I am going to give the data equals to abhi jo mera data hai, that is my data. Okay, this is what I want, and if I do that, let us see what happens. I just put, if I say put summary and mera underscore result, agar मैं ऐसा करता हूँ, what will happen? It has given me some values of f. Look here, this particular table actually looks similar to this table. देखो ना, ये जो टेबल दिख रहा है ना, वैसा ही टेबल ये भी जनरेट करता है. This particular table is called the ANOVA table. Okay, this particular table is called the ANOVA table, and this will give me the value of f, and it is also going to give me what is the p value here. Okay, now tell me, अगर मेरा 0.05 p value है, what does it tell me? 0.05 मेरा p value, यहाँ पे कौन सा वैल्यू दिया हुआ है? 0.1. कम है कि ज्यादा है? कम है कि ज्यादा है? 0.01 is smaller than 0.05, and therefore 0.01 is smaller than 0.05, and therefore what is happening? That means there is a significant difference between these three columns, these three treatments. This is what is the interpretation. There is a significant difference between these three columns. How do I know that? Because the probability, the p-value that I'm getting here is 0.01, whereas the level of significance that we have assumed is 0.05. Therefore, at 95% confidence level or 0.05 at significance level, the treatments are different. That is what I am trying to say here. Okay. Now, let us look at the PowerPoint presentation again. So this is the PowerPoint presentation that I've got. Okay, now I can do the Tucky test. Now I have to do the pairwise comparison. मुझे पता चल गया कि ये different है, but different कौन-कौन से हैं, यह मुझे कैसे पता चलेगा? How to say which one is more different? So what I have to do is use the Tucky test. Okay, and this is called Tucky honest significant differences test. Okay, so simply directly ये लगा देना है Tucky HSD command. Okay, so directly लगा देना है. So क्या करेगा? So I just say Tucky HSD लगाना है. कौन पे लगाना है? ये जो अभी मेरा रिजल्ट आया ना उसके ऊपर, मेरा रिजल्ट. Just do that, and it is giving me the comparison. Okay, the p adjusted value. This probability I have to see. कम है कि ज्यादा है? कम है कि ज्यादा है? मुझे वही कंपेयर करना है. Okay, and if I do the कम है कि ज्यादा है thing, तो कहाँ पे कम है भाई? Look at this. Treatment 2 and treatment 1, it is saying that they are different from each other, which is also confirmed. भैया हमारा देखो, ये जो मेरा बार बॉक्स प्लॉट बनाया था ना, ये बॉक्स प्लॉट इनिशियली बिना हाइपोथेसिस टेस्टिंग के आई हैव बीन एबल टू सी दैट लुक दीज टू ट्रीटमेंट्स आर डिफरेंट एंड ऑल्सो दैट हमारे ये जो मेरा एनालिसिस ऑफ वेरिएंस है वो भी बोल रहा है कि दीज टू ट्रीटमेंट्स आर डिफरेंट. So what I have done is I have confirmed it visually as well as statistically. This is I have done. Okay. So now let us go to the next thing. So now there is a two-way ANOVA test. अब ये two-way ANOVA क्या है? We haven't covered. I mean, I did not cover the two-way ANOVA. If it hasn't been covered for you, let me recall again. Two-way ANOVA क्या चीज है? Let us suppose again. Let us go back to the same Bonvita example. बोनविटा में क्या है कि बोनविटा एग्जांपल कौन सा, मेरे पास 4 हेल्थ ड्रिंक्स है. कौन कौन से? नंबर 1 आई हैव गॉट बोनविटा, आई हैव गॉट कॉम्प्लान, I have got Power Vita, I have got Maltova. So 4 health drinks are present. Okay. And then in a cosmopolitan city like Mumbai, in a cosmopolitan city like Delhi, there will be people from multiple regions. Say, for example, some people might be from Maharashtra, some people might be from West Bengal, some people might be from, Tamil Nadu, some people might be from Karnataka. Okay. So what I do is I make a table, number 1, with columns as the health drinks and rows as the state where they come from. Okay, the state of origin. And then I create a table. So then my factor A will be the health drink. My factor B will be the state where they come from. Okay, so then there is the first null hypothesis. So these are 3 null hypotheses which are there. Okay, 3 null hypotheses which are there. There is no difference in the means of factor A. There is no difference in the means of factor B. And then there is no interaction between factors A and B. मतलब कोई फर्क नहीं पड़ता whether it comes from Maharashtra or he is drinking Bonvita. कोई मतलब नहीं. Okay, so this is the concept of interaction. So now how do I know this? What do I have to do? I mean, okay, how do I know this? I have to do the two-way ANOVA. And of course, the alternative hypothesis says the means are not equal and there is of course interaction and there is visible interaction between A and B. This is what I have to see. Now, so assumption, what is again in the one-way ANOVA also and this the two-way ANOVA also, there will be assumption and the assumption is that observation in each cell are normally distributed and they have equal variances. So हम लोग क्या करेंगे, हम लोग एक एग्जिस्टिंग डेटा सेट है जो कि आर के अंदर अवेलेबल है, खेलने के लिए बहुत कुछ डेटा अवेलेबल है. तो हमको क्या पता है, आई मीन दोज पीपल हु हैव हैड हाउ डू से द टूथ प्रॉब्लम, जिनको ऐसे कैविटी हो जाता है ना अपने दांत में, तो उसके लिए रूट कैनाल करवाना पड़ता है. तो दे विल यू विल नो दैट व्हेन यू गेट दिस रूट कैनाल थिंग, people, the doctors will prescribe to you the vitamin C. Okay, the same way in guinea pigs also there is a certain dosage of vitamin C. अब guinea pigs हैं तो they छोटे छोटे animals होते हैं. So basically what they do is basically feed them with either orange juice or they feed them with ascorbic acid. The ascorbic acid is actually the vitamin C tablet जो आपके दुकान में available होता है. Ascorbic acid का जो tablet है that is vitamin C. Or they can indirect vitamin C, that is orange juice. And then if I छोटे जो गिनी पिग होता है उसको मैं विटामिन सी दूंगा तो उसके दांत लंबे होंगे, मतलब their teeth will grow. Okay, so and then what they have done is they have created they measured the tooth length. So again remember, अगर मुझे ये डेटा R के लिए स्टोर करना है, the way that we store in R is different from the way we store it in Microsoft Excel or LibreOffice or any other software. It's a different method of storing. So let us look at the data. We'll see how the data looks like. So again, what I'm going to do, I'm going to come back to this particular screen and I'm going to clean all the things here. So what we have to do is I have the data is, again, I just put as my data and it is tooth growth. Okay, so ये data है and let us see how my data looks like. देखो ये कैसा दिख रहा है. Okay, so this has got length of the tooth, and then there is a supplement which is being given. Either ascorbic acid being given to that person, as not person, the guinea pig, or orange juice is being given to the pig. Okay, the dosage is measured either in 0.5 mg, 1 milligram, or 2 milligram. So there are only three possible doses, and there are two possible supplements, and three possible doses. So supplement or dose का interaction मुझे देखना है. Please see this. Supplement or dose का interaction मुझे देखना है. Okay, so now how do I explore this interaction? वो मुझे देखना है. So how do I do that? First of all, the first thing that you have to do is to convert down, because only three possible levels of doses are there. I have to do some extra jugglery with the data so that I get the doses as levels here. So let us do that. Let us see what kind of jugglery we have to do. So look here. So this is the random display of the data. You can also do the same thing with the the data there. I am just showing you the live data set so that you can see. Now if I do the data structure, so you can see the data structure on the right side of the screen. You can do the data structure here, and also you can type str of my data. If I do that, then what will happen? It will also show you the data structure. So this is how the data looks like. All right, now what do I have to do? I have to convert my dose to levels. So how do I convert my dose to levels? I use the command called factor, and I will convert my dose to levels. This is what मुझे करना. तो levels and labels, ये तीन चीजें. Label अलग चीज है, level अलग चीज है. So I am going to convert this. So let us do it live. Okay. So what I have to do is, remember that मेरा field का नाम है dose और मुझे इसको करना है चेंज. तो आई हैव टू डू माई डेटा डॉलर डोज. ओके, ये किया. इसको मुझे ओवरराइट करना है. आई जस्ट डू फैक्टर. ओके, फैक्टर किया एंड देन इसमें डेटा क्या है? माई डेटा, ऑलरेडी माई डेटा, उसी को चेंज करना है डोज कॉमा. व्हाट आई हैव टू डू इज लेवल्स. So there are three levels that you have to do. First level is 0.5 gram, milligram, and 1 and 2 milligrams. Okay, and then I am going to assign them labels which are as. So this C is nothing but your concatenate command. So D, okay, 0.5 and then you have got D 1, okay, and then you have to say D. Okay, so let's D2. If I do that, then let us see what happens. Look here now. If I just type my data again, what has happened here is all those places where dosage was 0.5, it has come up as D. Thus D has been attached to the data. ये किया और कुछ नहीं. इसमें बस ये करने के लिए इसलिए है so that ANOVA करने के लिए मुझे आसानी हो जाएगी और कुछ नहीं. ANOVA बनाने के लिए मुझे आसानी हो जाएगी. So now let us again, I can do the GG box plot and all that here. You can see how the box plots look like. ये बहुत अलग दिख रहा है, ये एक साथ दिख रहा है. Okay, and ये अलग अलग दिख रहा है. Orange juice D2 में कोई फर्क नहीं पड़ता. Okay, orange juice और VC में यहाँ पे बहुत फर्क पड़ रहा है. यहाँ पे थोड़ा बहुत overlap है. So this is the visualization of the data. And again, I will like to repeat that visualization of the data is very important so that you can understand what is going on. All right. So now I can do the conduction of the one-way ANOVA test. Very simple. I can conduct the one-way ANOVA test. Now this test does not explore what we call as interaction. This test does not explore that. Let me tell you this. ओके, इंटरेक्शन के लिए अपन दूसरा काम करेंगे, कैसे करेंगे वो देखते हैं. So I am going to conduct the one-way and two-way ANOVA test. Two-way ANOVA test, I am going to do this. The length is a factor of the supplement and the dose. The dosage strength की बात कर रहा हूँ. The dosage strength is 0.1 or sorry 0.5, 1 and 2. These are the dosage strengths, and this is the supplement. It is either orange juice or it is ascorbic acid, and length is the outcome. This is what is the matter here. Right now, I have to conduct the two-way ANOVA test based on that. So how do I do that? Okay, so let us do that again now. मेरा result, okay, and मेरा result मैं जब कर रहा हूँ, please remember that I am not going to right now talk about the interaction. I will talk about the interaction much later. So the field name is length as a factor of supplement and dose. ये मुझे डालना है. And remember, I have to give the data also. Data equal to my data. So data important है, कौन से data के field से ये बताना पड़ता है. So now I am going to do that, and let us print the summary of Mera underscore result. If I done that, so what has happened here? It has given me ये क्या है, ये जो values देखिए आप, what is the value and what is my level of significance? Level of significance is 0.05. Okay, ये कम है कि ज्यादा है? ऊपर वाला 0.00429 कम है कि ज्यादा है? ये 10 to the power -16 कम है कि ज्यादा है? दोनों केसेस में ये कम वैल्यूज है, which means supplement is significant. It also means that dosage is also significant. दोनों चीजें important हैं. Okay, supplement and dose is very important. That means there is a difference in the means of supplements. There is a difference in the means of dosages. I don't know right now कि interaction support होता है कि नहीं. So how do I know कि मुझे interaction करना है? Let us do that interaction. I also do this, and मुझे सिर्फ इसको modify करना है, and modify करके मैं ये बोलूंगा, instead of writing plus I will write star. Star किया, that means I am going to study the interaction also. If I do that, again I'll just do the summary and look how it is happening. It has given me the fact that for supplement p value is 0.002. कम है कि ज्यादा है? कम है. That means supplement is significant. Dosage 10 to the power -16, 2 into 10 to the power -16 कम है कि ज्यादा है? कम है. That means this is significant. Supplement and dose, interaction between supplement and dose. Does dose influence the supplement? देखो 0.02 0.05 से कम है कि ज्यादा है? कम है. इसका मतलब ये भी significant है. That means there is an interaction also, okay, which we can see, which we had seen. मतलब अगर अपन ग्राफ देखेंगे, look here, there is an interaction. Okay, ये interaction दिख रहा है बहुत clearly from the graph also. So interpretation of the ANOVA result, the dose is seen to be more. यहाँ पे बहुत ज्यादा कम है ये वैल्यू, इसका मतलब this is much more significant. The dosage is going to affect more, or it is going to be more sensitive for tooth growth. Okay, it doesn't matter कि आप orange juice दीजिए या फिर आप ये दीजिए, क्या बोलते हैं आपका ascorbic acid, but what matters is the dosage. Okay, this is what is being taught here, and then you can actually create multiple pairwise comparisons. And again, since the dose is more significant, I am going to do the multiple pairwise comparisons of the doses only. Okay, ये pairwise comparisons मैं supplement पर भी कर सकता हूँ. That is what I am going to do. So I am going to do this Tucky test. Okay, again Tucky टेस्ट ताकि HSD, एंड कहां पे चलाना है? मेरा अंडरस्कोर रिजल्ट पे चलाना है. अगर मैंने चलाया एंड चला के मुझे क्या निकालना है? विच, कौन से पे चलाना है? ओके, सो नाउ यू जस्ट से डोज. इफ आई डू दैट ऑन डोज इट विल रन. So dose 1 and 0.5, dose 2 and 0.5, and between 2 and 1, between dose 1 and 0.5, look at the P. इसका मतलब बहुत ही अलग है. Dose 2 and 0.5 ये बहुत ही अलग है. Okay, and again this also is बहुत सारा अलग है. That means each of these doses is going to be significantly different from each other. बहुत clear है इस particular P test से अपन को मिला है. Now, so, and you remember during we were studying the parametric and non-parametric. I was talking to you about non-parametric statistics, and one of the things that we did was the gravel comparison. Remember the gravel example that we had कि city में ज़्यादा gravel होता है कि rural में ज़्यादा gravel होता है, ये वो वाला example है. And from there I have actually written one small code, और कुछ नहीं, ये urban के gravel के records थे, rural वाले gravel के records थे, ये combine किया data को और data को rank किया, और कुछ नहीं. I mean the same thing that we had done for ranking, we can do it in Excel also, and we can do it in R also. So that is done. And if I do that, it will give me, look at the value, look at the value here. ये 0.05 से कम है कि ज्यादा है? Please tell me. My audible. Please tell me whether this value is 0.05 से ज्यादा है कि कम है? 0.09 है. That means ये 0.05 से ज्यादा है, which means urban gravel and rural gravel same होंगे. It just means that from here, the what we have used is the Mann-Whitney paired test. Okay, and we also use the Kruskal-Wallis test, and we can use the Kruskal-Wallis test on the recent plant growth data. Remember the plant growth data? ये वही great data जो अपन अभी खेल रहे थे उसके साथ थोड़ी देर पहले. The Kruskal-Wallis test is here, and the Kruskal-Wallis test can be performed by using the command called kruskal.test. So I can do that, and if I do this, let us see kruskal.test, and just look at the p-value. Plant growth में क्या है कि treatment दिया है. So there was, if I just go back to R, please remember that in the, okay, I'll just clear everything here, and let us load the plant growth data again. If I load the plant growth data again, look at this. My data is plant growth. So this plant growth data, look at the plant growth data. So there are three different kinds of treatments. One is the controlled one, there is treatment one, and there is treatment two. This is how the plot looks like. Okay. And if I want to find out the difference in the treatments, whether there is a difference of in the treatments using the Kruskal-Wallis test, this is how it is, and the weight has to be compared against the groups. Okay, the groups are nothing but your treatments, so it's the same thing. So let us go back. So I have to just run the Kruskal test, Kruskal dot test. Okay, and the weight has to be group. Is it groups, right? Group. Okay, group. If it is group, and then the data equals to my data. So you have to mention कि कहाँ के fields हैं. So my data, I just did that. So if I do that, it has given me that my p-value is 0.01, which means it is less than 0.05. If it is less than 0.05, इसका मतलब वो अलग-अलग. Okay, so the treatments are different from each other. Again, I don't know. मुझे नहीं पता कि ये अलग-अलग हैं या नहीं है. Okay, so if I have to really find out the differences between the treatments individually or pairwise difference in the treatments, the technique is to use the multiple pairwise comparison between groups, and the technique is to use the pairwise Wilcoxon test, and this is how it is. And you can use the Bonferroni test, and from the slide that you can see on your screen, I can use the Bonferroni test, and here look at this value here. Which one? ये जो है, there is no difference, which means it is greater than p, मतलब alpha equal to 0.05 से ज्यादा बड़ा है. This one is बड़ा वाला, so therefore that means there is no difference. Control or treatment 1 में कोई difference नहीं है. This is 0.1, ये बड़ा है 0.05 से. Control और treatment 2 में कोई difference नहीं है. But look at this, it is 0.027, which is less than 0.05, which means treatment 1 and treatment 2 are different. Okay, so this is what it means from this particular table that we are seeing right now here. Okay, now if I look at this, it means that these two are different, but I cannot say anything about these two. I cannot say anything about these two. That is what it means right now here. From the data, it means this. So I remember that while I was talking to you about the Kruskal-Wallis test, we were talking about the Dunn-Bonferroni test, and the Dunn-Bonferroni test is right here. Okay, and you can also, there is another test called the BH test, and you can do the same thing. The output of the BH test is also the same here. Right now, what we are seeing. Oh, sorry. Was it audible up to now? Okay, so right now what we are seeing right now is 0.027, and this is significantly different. That is what it means right now. So these are the references. So there is this website called STHDA, the Statistical Tools for High Throughput Data Analysis, sthda.com, and Jared Lander. So this is the book which is available. This book is available on Kindle, as well as this book is available for purchase. I believe that this book is good, and you can use it on Kindle actually. No need to go for the, I would say, the hard copy book, but this is how it is. So that's all for today. For understanding the statistics with R.
Hello, sir.
Yes.
Sir, are you going to provide us some notes about this one?
I am going to provide you the slide. I can provide you the handouts of the slides. If you want the handouts of the slides, please tell me.
Yes, sir.
Okay. Acha. Also, I would like to tell you that I have actually generated these slides using a command. I mean, using a code. तो ये जो मेरा कोड है, ये देखिए on your screen you can see the entire code is written on the screen. हाँ? तो ये जो PowerPoint है ना, ये मैंने यहीं से बनाया है using my R. तो R से मैं PowerPoint भी बना सकता हूँ, R से मैं Word डॉक्यूमेंट भी बना सकता हूँ. मुझे सिर्फ R चाहिए और R Studio चाहिए. I can do wonders with that particular software. So yes, I can at the end of yes, of course I am at the end of the session, but I can actually provide you the handouts of this particular slide on WhatsApp. Is it okay? Or yes, on WhatsApp I can provide, right? Or even on Teams I can provide.
Fine, thank you.
Okay. So ये बड़े करके भेजता हूँ मैं, because for this I think the font needs to be bigger, so I can give you individual PDF handouts, no problem. बड़ा वाला चलेगा ना आपको?
हाँ sir, ठीक.
Yes.
Thank
Any
you,
more questions you have?